We're now going to use these Pythagorean identities that we've just proved to solve some equations. So these are Pythagorean identities. 1 plus cot squared x equals cosec squared x, and 1 plus tan squared x equals sec squared x. So we're going to use it to solve these two equations in this range given. Now the problem here is we've got more than one type of trig function. So the method always is to try and get it in terms of just one trig function. So I'm going to use the second of these identities for A, and I'm going to first of all try and split this first part up so that I can write it in terms of 1 plus tan squared x. So if I rewrite this as 2 tan squared theta plus 2 plus 6, I've split the 8 up into 2 and 6 there, and that's equals 7 sec theta. I can now factorise this first part and take a 2 out. I've got 2 tan squared theta plus 1 plus 6 equals 7 sec theta. And that's good because we know that 1 plus tan squared x is equal to sec squared x. So we can say that's 2 sec squared theta here plus 6 equals 7 sec theta. Good thing now, it's all in terms of one trig function, and it's looking like a quadratic equation. So what I'm going to do is take everything over to the left hand side and make it equal to 0. So I've got 2 sec squared theta minus 7 sec theta plus 6 is equal to 0. And I'm going to try and factorise this. If you wanted, you could just make it in terms of x. So x is going to be equal to sec theta. And then obviously your quadratic will reduce to this. And just use the calculator function to solve it to get the values of sec theta. So if I factorise this, then what I've got is 2 brackets. So I've got 2 sec theta in the first one, sec theta as second. And I'm looking for two numbers which multiply to make positive 6. So I'm going to say minus 3 and minus 2. And so that means the 3 is going to have to be there and the 2 is going to have to be there. And if you want, check by multiplying this out and you should see that you'll get this quadratic above. And so that would mean that either the first bracket's got to be 0 or the second bracket's got to be 0. So if the first bracket's 0, 2 sec theta minus 3 is 0, which means that sec theta is 3 over 2. And from the second bracket, sec theta is just 2. So we now want to try and convert that into cos because our calculators don't work have a sec function on them. And so what we're going to say is, well, since we know that sec theta is 1 over cos theta, then we can just invert the fraction. So we can flip both sides of these little equations we've got. We can say, well, cos theta then must be 2/3, and the other value is that cos theta is 1/2. So now what we need to do is we actually need to find the value of theta in the range that's given, so 0 to 360. And because it's given in degrees, we need to make sure that we're in degrees mode for this question rather than radians. So we must set the calculator to degrees for this one. So we get the working angle. So theta is, for the first one, cos minus 1 of 2/3. And that will give us 48.19. And so if we look at a cos graph there in the range 0 to 360, it looks like that. So what we've found is this angle here, 48.19. That's the 2/3 point. And the other solution in the range is 360 minus the 48.19. So 360 minus 48.19, which is 311.81. So there's the two solutions from the 2/3. And if we then look at the solutions for the half, if we do theta is cos minus 1 over half, then that gives us 60 degrees. And using the same process, take that away from 360 because we've got this point here is 60. Well, if we project it across, we can see that it's the same distance from 360 in the opposite direction. So it's going to be 360 minus 60, which is 300. So these are our solutions in that range. We now look at B. So this time we've got cosec squared theta equals cot theta minus 1. So we're going to again try and get this all in terms of one trig function. And this time we're going to use the first one, 1 plus cot squared equals cosec squared. So we're going to replace the cosec squared by the 1 plus cot squared x, which it says it is. So in this case, we've got theta rather than x as to label the angle. So we can write this as being 1 plus cot squared theta equals 3 cot theta minus 1. So again, this looks like a quadratic, as these sorts of questions often do. So we're going to take everything over to the left-hand side. So we're going to say, well, if we do that, we've got cot squared theta minus the 3 cot theta, if we take that over to the left-hand side. And then we've got the 1 we already had here. And then I'm going to take that over the minus 1. That's going to become positive. So it's going to become a plus another 1. That's all going to be equal to 0. So if I tidy that up, that's going to be cot squared theta minus 3 cot theta plus 2 equals 0. And again, like the previous example, you could rewrite this in terms of x, so that it's quadratic. You're going to so if you say x is equal to cot theta, then this would turn into x squared minus 3x plus 2 equals 0. And then you use calculator to find values of x, which are then cot theta. I'm just going to factorize this one. So we're going to have cot theta at the start of each bracket. The two numbers have got to multiply to make positive 2. So I'm going to say it's going to be minus 2 and minus 1. So if I put those in, that would actually multiply out to give us the quadratic above. And obviously check that. So then from that we can see that cot theta, to make the first bracket 0, would have to equal 2. And from the second bracket, cot theta would have to equal 1. And we're going to put it into terms of tan, because we can't easily put this one into our calculator in terms of cot, but cot is equal to 1 over tan theta. So what we can just do is invert both sides of these equations. So we can say, well, if that's the case, then tan theta is actually the reciprocal of 2, which is going to be a half for the first one. And for the second one, tan theta, 1 over 1 is still 1. So we need to then use the inverse function on the calculator to find that theta is going to be tan minus 1 of a half for the first one. And for the second one, theta is going to equal tan minus 1 of 1. So we need to solve those, or put them into the calculator to get the working angle. So if we do that, then we'll get the working angle for this one is going to be 26.57. And for this one, we get theta would be 45 degrees. And if we think about a tan graph, then a tan graph has got asymptotes at 90 degrees and 270 degrees. So we can draw those in. And also passes through 0 at 0, 180 and 360, where it crosses the x-axis. So that's the tan graph in our range. And we can see that if we get a working angle, so this first one, 26 degrees, which is equivalent to a half there, so 26.57, we can see that because it repeats every 180 degrees, we can just find any other value by adding or subtracting 180 degrees. So within our range up to 360, we've got another solution here, which is that 26 plus 180. So that's going to be 206.57. And also for this 45 degrees, which is here, if we add 180 onto that, we also get the other solution in the range. So that's going to be 180 plus 45, which is 225 degrees. And that's it. These are all our solutions in this range required. Again, I'll just point out that that's in terms of degrees, so we need to be set to degrees on the calculator.